If you want to hold tight for 1 minute. It's always going to load. Nice. With a laser pointer. Okay. Well, with that, I'm going to introduce Chris Benedict, professor with Washington State University, talking to us about spot spray technology for use in small fruit production. Take it away, Chris.
Thanks, Betsy. I'm just going to actually play this video again. So I spoke about this last year. This is a project that's been actually going on since 2021. It started with an intensive weed survey that we did in commercial fields, and I'll actually talk about that. But what we're looking at is a video of a spot sprayer that we trialed in 23 and 24. And I'm going to talk about that as well as a second project that I'll get to in the end. So this was the result of the survey. If the weed survey, if people have seen this before, I apologize, but it made a couple really important points that I want to point to because it justifies a lot of this work. That in both the spring, when we combined data from the spring and a fall assessment, we saw that over 3/4 of the assessment areas contained no weeds. So these are in commercial fields. This is about 40 different fields. And what that means is that weed distribution is very patchy in fields, okay? And industry standard is to spray herbicides, whether there's weeds present there or not. Obviously, with pre-emergent herbicides, you're not going to rely on that. But for post-emergent herbicides, which is the most commonly applied type of herbicide in northwestern Washington, but we do see patches of significant amount of weeds, 30, 40 in a meter area. So very high density, but sporadically throughout the field. And this actually lends itself a lot to the use of spot spray technology because it's only going to spray when there are weeds present. This is a little bit of an overview of what we did. We took 2022 off from this project, but finished it up this past year. So there's a ton of different manufacturers. I'm going to take a minute and talk about the technology, the equipment. We were hoping to actually have our sprayer here, but logistical issues, we couldn't get it here. There are tons of different manufacturers. There's 3 major, the one that we utilized is reliant on a laser sensor. And you can see that sort of on the soil here, that's that red line. And as the boom passes over the hill, the field, if it senses something that's green, it triggers that nozzle. And you can see in this video here, this boom, we had a single side boom, had 4 different nozzles. So there's 4 zones that are controlled by that spray, by that sensor. And it only triggers when it finds a plant in that zone, okay? And you can see sort of the distribution of those zones here, and it's currently cycling through all 4 of them. So that's what this looks like. This is actually, I shot this yesterday. I don't know if this is gonna work, but we'll try. This is the actual spray machine that we use. It's a 1950s tractor with a 2024 piece of equipment on it. But what it consists of, the point of what I wanted to show you here is there's essentially 3 components. This image isn't great, but there's the sensor itself and then the solenoids that it controls. And this big white box here is a computer. So it's pretty beefy. And then there's a control box that you can see right here. And that allows you to switch from basically 4 different modes, of which includes broadcast. So you can use the same boom to broadcast an herbicide. So this is a list of all the trials that we did. You can see that they're fairly extensive, 2023 and 2024, tested it both in blueberries and in raspberries. I'm not going to go through this, but 2023, we only had post-harvest applications, and in 2024, we had both pre and post-harvest. It initially sort of observations is that it would work really well pre-harvest where there already is low weed density. But you can imagine in caneberry situation, you've got primocanes coming up. So they're triggering that machine just as much as any weed would, right? Which isn't necessarily a bad thing if you're at the cane burning stage. So this is how we assessed everything. We had a pre-application, just prior to the application, weeds were counted and the height measured, the herbicide was applied, and we measured the amount of herbicide that was applied for each and every plot. And we did that for both of the treatments. We had a spot spray treatment and a broadcast treatment. Timings of herbicide applications were driven by growers. And then at 14 days after that, we recounted those same quadrants and weed biomass was taken, and then a couple visual assessments were done. And then additional visual assessment occurred about 2 weeks after that. This is our way of sort of tracking that change in that population in time. So I'm going to go through a number of these fairly quickly, and they're going to all pretty much look the same. This is the amount of product that we applied. What's important here is actually look down here. This kind of gives you the take-home message. In 2023, the spot sprayer reduced between 2.5% and 72% of herbicide that was applied by the broadcast sprayer. So up to 3/4 of that total amount of product applied. This is in a post-harvest situation. And I should mention, let me just hide this. This is in blueberries. And what we saw in 2024 that we did not have as dramatic as a reduction, but that occurred anywhere between 0 and a 1/3 reduction. Now I'm going to come back to these numbers later when we talk about economics, but we look at raspberries. Nope. And one of the things I want to point out is that in some of these trials, we applied the same amount of herbicide with that spot sprayer as much as a broadcast. And part of that has to do with that it's triggered by anything that's green. I showed this image last year. This is moss, very common thing on fields. I think that there might be a discussion if this technology is adopted widely about possibly trying to manage that. There's sprayable products that you could actually apply to take care of that. But obviously in a fresh sawdust situation, that's going to be totally different. But so let's look at, now we're going to first look at weeds and blueberries. And again, we did a pre-count and a post-count. I'm only showing you the post-count. What you're looking for here is when it comes to the weed population, spot spray technology should act the same as broadcast, if not better, right? If we're trying to replace a technology, we want it to act the same way as our previously adopted technology, right? So, and what we find here is across both years and across a couple different trials, there was no difference in weed density after application. So the spot spray was as effective. What that means is that spot spray is as effective at reducing weed populations as the broadcast. The same goes for biomass. One of the things that you'll note is, anyone that's been out in berry fields, is sometimes you'll get a couple really big weeds. And what they're doing is they're creating the future populations, essentially. Weed biomass is very correlated with weed seed production. And so this is a good proxy for our ability to reduce that seed production in those fields. And what we saw across both years and both trials is that there was no significantly higher amount of weed biomass in those spot spray trials compared to the broadcast. So we're going to switch over to raspberries, and I'll bounce through this a little bit more quickly. 2023, between a 20% and a 53% reduction in herbicide. And then in 2024, there was a lot more trials, but that range went anywhere from they were the same up to 71% reduction in herbicide application. Now, as we saw in blueberries, there was no differences between these treatments. Again, that means that the spot sprayer is as effective, and also no differences in weed biomass. Now, this is where kind of the rubber hits the roads. This is all about economics, right? That sprayer that I showed you costs about $10,000. It's a single boom. It's on one side of the row. Most growers are hitting 2, if not 4 at once. And that 4-zone sprayer is going to have to be on each side of the hill. So just do the math there. But what's interesting here is if we look at those at the results of both blueberries and raspberries, we see, and I picked three scenarios. These are kind of lowish reductions in herbicide and highish reductions in herbicide. So spot spray, this 10% means it reduced herbicide application by 10% versus 33% versus 72%. So high and low. And then we compare that to broadcast. And we just look at herbicide costs, right? We're not talking about equipment. We're talking about what it costs to apply that product, because herbicides are not cheap, as many of you know. And what you can see is in a low sort of ability to reduce herbicide, the 10%, that the cost is obviously less than broadcast. But what it gets interesting is when you look at this 72%, that high range, it's 3 applications in a given, let's say in a given year, are cheaper than 1 application of broadcast herbicide. Okay, so what that means in the case of blueberries, and what that means is that the payoff period for this is roughly about 6 to 7 years. So you'll be able to pay off the equipment, and that's based on a 50-acre field. Okay, so it changes, and what we're not comparing, what that value does not have in is if you grow both blueberries and raspberries. So you're using it on multiple crops. And in raspberries, same scenario as you can imagine, 2 or 3 applications at that moderate reduction in herbicide or that high reduction in herbicide are less expensive than a single application of broadcast. So this technology at this point has shown that it can reduce money. What isn't so great about it? Let's talk about that. So as I mentioned, variable reduction. So that's going to be different for each grower, for each field. And I think if you're serious about looking at this, you might want to look at how dense your weeds are and look at, we're going to put out a publication where it's going to have a relationship between cost of return and weed density. So you could actually estimate whether or not this is going to be an economic thing, economically viable. And I mentioned similar herbicide delivery and reduction of weed biomass. This year we included pre-harvest trials. They were different in caneberry and raspberries. They were much more complicated because of the caneberries. And what can result from that is a spotty application of cane burning. So if you're using that, I would not suggest using the spot sprayer during that time period for cane burning, but it can work in and around it. And some of the questions that I walk away from this project looking at is, can more frequent applications be made? So we saw that they're cheaper, even if there's more of them. I'm not advocating just going out and spraying more, but if they're cheaper and you can spray them more, can you slowly reduce your populations over time? Could there be cluster applications where you go in and you apply both a post-emergence and a pre-emergent? Multiple product delivery. Some of the other new sprayers in things like corn and wheat, they have dual nozzles and they can apply both at the same time. What I've seen, a lot of this technology is used in Eastern Washington. What I've seen over there is some really interesting innovation where they're using a sensor with a post-emergent and they're applying a pre-emergent with a second nozzle. They have 2 different tanks and they're making that. I think that's something to possibly look at for this industry because we have, as many of you know, we have very narrow windows of opportunities to actually knock back weed populations. And then you kind of have to ride it through harvest. In some cases that could be 6 weeks, right? So, and as I mentioned before, you can easily switch to a broadcast application. It's literally switching a button. So if anyone is interested in looking at this equipment, want to get closer up to it, we can make that happen. I apologize, we couldn't have it here today. So I'm going to switch gears and talk about another project. We'll get to questions in the end. So after, as I mentioned in that weed survey, we identified weeds to species. And so we have a pretty good idea of what is sort of causing the problems in a lot of fields. And I think it's a fairly thorough documentation of that. And some of the conversations that I've had with some growers is that increasingly some weeds in the Polygonum family are becoming more problematic. And we put together a project that was funded by the Washington Blueberry Commission we'll talk about today. So there's several key species. I'll talk about those here in a second. Really, the key here is reducing seed production. Seed lives a long time. They're highly prolific, and that is their main mode of reproduction. A single plant dropping, 4,000 to 5,000 seeds, it's just going to be 4,000 to 5,000 potential plants the following year. Some of these species, their seed half-life is 15 to 20 years. So any one seed rain event can have significant impacts for years to come. There are several herbicides registered in in this case, blueberries, but timing is really critical. And that's where this project sort of attempted to take a tact at this, is to find better windows for when apply herbicides to control these weeds. And lastly, a predictable seed reduction tool, I think, could be really helpful. This would be driven by biology, some previous work that was done, I'll get into. So as I mentioned in that weed survey, this is the major weed families that we found. These are organized by fall and spring. That is roughly April, May-ish, roughly September-ish. And we can see here, one thing that stood out to me is that the weeds in this family can represent up to 25% of the total weeds that we're seeing in commercial fields. And that is up from 5% from the spring. They're summer annuals. They're going to germinate late spring, early summer, but they're getting through herbicide programs. And that is, I think, a really key thing here. So I'm going to take a second, just talk a little bit about these. Most of you have seen these. This is prostrate knotweed. You typically see this growing in the grass alleys, and it will kind of creep into the hills. A lot of people make skirting applications to try to prevent that or knock it back. It is less prolific than the other two that I'll talk about, but it can produce a lot of biomass. Second is wild buckwheat. This one I think is probably the most problematic because it has this really lovely growth habit that can get up into the canopy. And once it gets up in there, even if you hit it with an herbicide and it's not a systemic herbicide, it's still going to keep maturing and produce seed and drop that seed right into that base. And any hand weeding crews you try to get in there, people tend to rip at it, and it just literally rips the bottom portion out and doesn't actually remove the plant. So again, and it will continue to produce seed thereafter. And one that represented about 70% of the weeds that, in this family that we counted is lady's thumb. It is very prolific as well, and it has a very short time period from emergence to seed production. Like actually, almost all of these do, but this one in particular compared to the other two. So we submitted a proposal to the Blueberry Commission. It was funded, but it got delayed. And so we actually weren't able to fully do this project. So I'm going to talk about what we can, but this is sort of what was outlined, sort of two major objectives. One is herbicide efficacy. So this is a screen. Alan just showed, actually there's a list here of the screen the products that we used. This is sort of looking at everything that can work and seeing what is effective. The second is, and this was not performed, is looking at that timing piece. I think this is where the struggle is the biggest. There was some previous work by Steve Seefeld and myself that looked at, and Brian's here, oh, there he is. It looked at developing a growing degree model so that the seed production component of it could be predicted. And that helps with timing. And unfortunately, we didn't get to do any of this because the funding didn't come through until the middle of the summer. But for the herbicide trial, we took basically everything that's registered for the most part and did a couple, and everything was applied. This is post-harvest. And so this is post-emergence only. And so anything that had either a pre-emergence or dual activity was included with a post-emergent contact herbicide. Everything was applied with surfactants, just like we did in the spot spray trials. Weeds were counted beforehand, and then a visual and then a density thereafter included with a biomass. And visual assessments were done up to about, I think, 50 days thereafter. Just some walking through these products. Nothing, new here. These are all registered in the U.S. This product right here, Quinclora, Quinstar. Who's heard of that? I'm kind of curious. Yeah, I suspected this. This came actually a conversation with a grower, and it's actually it's mostly utilized to control crabgrass, but it does have activity on these weeds, and is a very interesting product that we'll talk about here in a minute. So I'm going to show you the results. These are 14 days after treatment. That's the DAT. 25 days after treatment and about 40 days. And this is all the products in that list. Obviously, we have a non-treated control. Obviously, there's not much control going on there. But what I'm going to do is, just to make this easier to look at, I'm going to take everything away that's not at 75% and just limit it down. So this is looking at the same results, but any product that was 75% or better control of any one of these species. We didn't have a uniform. Not all three species were present in every plot, so we were using them as proxies. But and what we can see is that there's actually several products that were really quite effective. And as early as 14 days, the gramoxone and cheetah were effective. And you'll see here Quinstar. This is the high rate. Notice that it was applied at the label. Allows up to roughly 12 ounces a year. So there was a single application at 6 ounces and a full application at 12 ounces. And that 6 ounce never really got above that 75% threshold. So it's not included here. But what you'll see here is that these contact products were all very effective kind of out of the gate. And but Quinstar, because of its activity, the way that it impacts plants, is it actually takes a good amount of time before you start to see symptoms on the plants. And that's why you see this bump up into 40 days. Now, what we didn't do yet, or we hopefully will be doing next year, this project's going to be resubmitted, and hopefully we'll get funding early enough that we can do all of it, is to go back to these plots and look at what has changed over time. Because this is useful, but it's not meaningful, because what we need to do is reduce weed populations over time. These weeds that died out, some of them are still clinging into the canopy, and that seed production is more than likely, it's potentially there because simply of the biomass that was there. So, and as I just mentioned, really curiosity about what is the long-term weed reduction. This is the ultimate goal. A given year is one thing, but how do we reduce that seed production? For the first part, that's getting that early season knockback and then preventing seed production post-harvest. And I mentioned this earlier, that twining or prostrate growth habit, herbicide efficacy can be highly variable, because you might contact one part of the plant and it's still able to survive on another part. Obviously, a systemic herbicide would be useful there, but we don't really have much in that that's safe to apply that close to plants. And then, as I mentioned, seed production in the context. Next year, we're hoping that the commission funds this again to do the whole work, is to look at applying the spring treatments based on growing degree days, because we know at a certain growing degree day threshold that plant is going to start setting seed, and it becomes a long-term threat rather than a short-term issue. So really hoping to include that. And as I mentioned, we'll expand some of the herbicides into those pre-harvests, including some pre-emergent products. And my hope is to do some estimates of seed production in the treatments. So with that, I'm going to put up Chakradar's survey. If you could, it's $20 you get, right? If you do this on Amazon, so take the whatever minutes it does to do it. All your information's not held on to. I'll leave that up by during time if anyone has any questions. I know there's like food and drink right there. So if you don't have anything, urgent, we can just move on to that part of the day. So any questions?
Got one.
Hey, Ark.
Hey, you let us Canadians out of our cage and we just don't shut up. Yeah. Um, did you notice any spray drift issues with the spot sprayer, or were you using like a variable frequency drive or some sort of different nozzle so that when it was going on and off, it wasn't drifting?
Yeah, that's a great question. And in fact, if you look at the manufacturer's handbook, they want you to recalibrate your nozzles much more frequently than I think a lot of other manufacturers would because of that issue. What Eric's getting to is that triggering on and off, is it adamantizing more frequently because you're shutting on and off? We use flat fan nozzles, pretty standard issue. They don't, one thing I should mention is the system that we use, they have pre-programmed nozzles in it. So you can only use certain types of nozzles, and they do that because, it comes down to the mechanics within the solenoid, but that's it. Thanks for the question. Did I address that? Yeah, okay. And make sure to get your QR code scanned and get that.
Is there certain ground speed for that laser?
Sorry, I can't hear you.
Is there certain ground speed you have to go?
Oh, great question. Thank you. That's actually a really good point. There's a GPS that is included with this. So the faster you go, the quick, you have to program into it the distance between the sensor and the nozzle so it knows to delay it, right? So the faster you go, it's giving you real-time readout on your speed on that little display that I showed. And so it's compensating for that. You can apply up to 15 miles per hour, but I don't think anyone's driving in berry fields that fast. So yeah, but it's the technology's there. It frankly really is. And it's being used on a lot of acres in east of the Cascades. I think there's a question. No?
Never mind.
Oh, yep. So I think the question was, if you have a big mass of weeds, does it slow down? Betsy, can you give him the mic? I can't.
In blueberries, you got couch grass and that. It's a hard weed to kill.
Yeah.
So it's spotty. So when you do the conventional, you kind of slow down a bit and just, take it as how much weeds are present in the field.
I think you're asking if there's a big clump, is it able to sort of compensate for that big biomass? Yeah. It's going to trigger, I really wish we had it here. It's going to trigger based on, so it's two-dimensional, I'll put it that way. So it's not looking at, okay, here's biomass, I need to calculate how much herbicide to apply. It's simply saying there's something green there between here and there, I'm going to spray all of that. Yeah, and if anyone gets one of these, I highly recommend getting spray dye. You can see it. It's pretty useful to, although if you can get it all over everything. Anyone who's ever used spray dye. Anything else? Thank you all for patiently waiting around. I think it's pesticide credits, right?
Yes. Yeah. So if we'll get pesticide credits, I believe. Great talk, Chris. Thank you. Yeah, I believe the sheets are out. And so we're asking you to, both do the sheets, write your name down like usual, but also get your badge scanned by our friendly scanners who are the same people you saw on your way in.